What if everything you thought you knew about gravity was wrong? Not just a little off, but fundamentally misunderstood for centuries. What if that familiar tug pulling you down to Earth isn't a pull at all? Imagine standing on the edge of certainty, only to find out the ground beneath your feet isn't as solid as it seems. For generations, we looked up at the stars, fell apples, and floating astronauts, and thought we understood why things fall. But now, that comfort is beginning to unravel. We were raised with the idea that gravity is a force that pulls us down, keeps the planets in motion, and chains us to Earth. We step on a scale, see the number, and accept it. That's gravity, that's weight. Simple. We've watched animations of black holes pulling light inward, and diagrams of the sun pulling planets like marbles on invisible strings. This idea of a magical force, ever present and silent, has been stitched into the way we experience the world. But what if it's all an illusion? What if, instead of a force, gravity is something far stranger? Long before Einstein was even born, a man named Isaac Newton dared to ask a question most people ignored. Why does an apple fall straight down? Not sideways, not upward, but directly down. Newton imagined a force, invisible yet powerful, reaching out between objects with mass, a kind of cosmic handshake that grew stronger with proximity and weaker with distance. He imagined a world where mass pulled on mass, where every object was magnetized toward every other. And for centuries that explanation worked. It shaped our science, our machines, our understanding of the universe. But even Newton felt something was missing. He didn't fully buy into the idea of a magical force acting across space. Something gnawed at him, a quiet suspicion that his explanation wasn't complete. He believed gravity might not be a pull at all, but perhaps a push from somewhere else. And then, more than 200 years later, a soft-spoken patent clerk named Albert Einstein shattered everything. Einstein saw the same universe as Newton, apples falling, moons orbiting. But what he felt was different. He didn't see a world where masses pulled on each other like magnets. He saw a fabric that bent, twisted, and curved under the weight of existence. What we called gravity, he said, was not a force. It was the bending of space and time itself. It wasn't that the apple was being pulled. It was that the apple was sliding along a curved path in a warped world. Imagine placing a bowling ball on a trampoline. It sinks the fabric downward. Now roll a marble nearby. It doesn't head straight toward the ball. It spirals inward, drawn not by a pull, but by the very curve in the surface beneath it. That's gravity, Einstein said. Not an invisible tether, but the shape of the universe, changing around mass. But if gravity isn't a force, then what is falling? What does it mean to weigh something? How can astronauts float just beyond the reach of Earth when gravity is still very much present? The truth is, those astronauts aren't floating at all. They're falling. Constantly. Everything up there is falling. The space station, the satellites, even the astronauts themselves. But they're moving sideways so fast they keep missing the ground. That's what orbit is. It's not suspension. It's perpetual free fall. And here's the strangest part. If you dropped a hammer and a feather on the moon, they'd hit the ground at the exact same time. That's not science fiction. It actually happened. On live video. Because when you strip away the air, the resistance, the noise, everything falls the same. Why? Because in the absence of outside forces, every object simply follows the path carved into space-time by mass. It's not being pulled. It's falling along the shape of the universe itself. But this goes even deeper. Einstein didn't just say that space was warped. He said time was too. That the closer you get to something massive, a planet, a star, a black hole, the slower time moves. It's not some metaphor. It's measurable, real, and terrifying. The universe doesn't just stretch and bend where there's mass. It ticks differently. Seconds aren't universal anymore. Gravity, it turns out, is the universe folding in on itself, changing both direction and duration. This strange bending of light and time has been seen. Light from distant stars curves around galaxies, making rings in the sky that shouldn't exist. We call them Einstein's rings, beautiful halos of warped reality. One of the most famous examples, Einstein's cross, shows the same object appearing 4 times, not because it's multiplied, but because the light bent around a massive galaxy in front of it. That bending isn't optional, it's inevitable. Mass reshapes the universe. Even light must obey. But as brilliant as Einstein was, even his masterpiece has cracks. At the edge of black holes and in the small-scale chaos of particles, his theory stops working. Space-time stretches too far, time breaks, and suddenly everything unravels. Scientists watched a blue star, SO2, race past the black hole at the heart of our galaxy. According to Einstein, its light should have stretched, redshifted, under the pull of gravity. And it did. Perfectly. But that's the problem. It shouldn't be perfect forever. Somewhere out there, hidden in the folds of extreme space and unimaginable time, lies a place where Einstein's vision fails. And we're getting closer to finding it. Closer to the moment we might have to say, he was wrong. Just like Newton before him. It's a humbling thing to watch giants stand tall and still not reach the end of the truth. Newton's apple showed us there was more to the sky than we understood. Einstein's fabric showed us the sky wasn't even what we thought it was. And now, we wait. We search. For the next whisper from the universe. For the next mind to reshape reality. Because gravity, that familiar word, that everyday experience, may not be a force or even a thing. It may be a whisper in the structure of existence, a curve in the silence, a clue that the universe is far stranger than we ever dared to imagine. And one day soon, someone will find what even Einstein couldn't. And when they do, we won't just rewrite textbooks, we'll rewrite reality.